Hello and welcome to DataBelt. My name's Matt Smith and I'm Head of Pre-Sales at AIM. In this video, I'm going to be covering DataBelt's ability to discover and process rot data, that is data which is redundant, obsolete or trivial. However, DataBelt is a complete data discovery, classification and governance tool. So for information on the other diverse use cases that DataBelt supports, please have a look at our other videos in this series. Let's start with defining exactly what rot is. Well, it stands for data which is redundant, obsolete, or trivial. It's data that is no longer, or possibly never was, of use to an organisation. The Venn diagram here represents the reality of the situation, whereby a file, a document, could fall outside of this Venn diagram, or it could fall into any of the 7 segments that exist within it. For example, a duplicate copy of a personal email that was sent 10 years ago, as we'll see, may well be defined as all three. It is redundant, obsolete, and trivial. Let's start with redundant. Redundant data represents duplicate data, either within the same system or location or another. A couple of examples here are duplicate copies of an employee's passport within a HR system, or a duplicate client record within a CRM or sales system. Obsolete data is either inaccurate or no longer in or of use to the business. Inaccurate data may take the form of a file containing an old company address or telephone number, while a Word document which was last accessed 5 years ago, or a spreadsheet containing no data, are examples of data which is no longer in or of use. Finally, trivial data represents personal files such as photographs of pets, or perhaps personal party invitations created and stored on company devices. Other examples may be movie or song downloads for personal use. But why is rot a problem? Well, firstly, it's a problem which isn't going away and is actually increasing in size. Data volumes within businesses are growing, sometimes exponentially year on year, and some estimates put the rot issue as affecting around 1/3 of business data. It also represents a risk to businesses, as rot may contain PII, or personally identifiable information, PHI, or personal health information, and PCI, payment card industry data, such as credit card information, especially within the trivial parts of rot. Rot increases business costs too. More data simply requires more storage. It increases maintenance costs, and you may well be storing rot data on expensive solid-state storage devices instead of lower-cost alternatives. And naturally, backups are larger too, especially if 1/3 of your backups are actually rot. Rot also plays havoc on reporting. Organisations are increasingly interested in reporting on the quality, value, size, type, and location of their data, which is exactly what DataBelt is used for, coincidentally. But with 1/3 of your data being rot, data reports are inaccurate, and businesses may be making incorrect decisions as a result. We recognise the scale of the challenge and the value that removing rot brings to businesses. As a result, DataBelt contains a dedicated rot console and some very sophisticated rot discovery and processing capabilities. And we're going to see DataBelt now, covering our 5-step process to becoming rot-free. Firstly, we're going to define our criteria for obsolete and trivial data. We then index our data so that it can be searched at lightning speed. And next we run our rot analysis, either manually or through scheduled processes. DataBelt will then either automatically tag the data as it finds it, or we can choose to do so manually. We can then process the ROT data, either by deleting it, moving it to another location, such as a lower cost storage area, or leave the data in place to be picked up by automatic retention policy processes. And as the removal of ROT is not a one-off action, it's an ongoing process, we can report on ROT over time using our data landscape module, and we can rerun our ROT processes at the required frequency. Okay, so I've now logged into DataBelt, and I'm just going to jump into our configuration management database because there are a couple of things that I want to go over and explain before we go through our ROT process. These two things underpin DataBelt's capability. So those two things are just here, regexes and keras models. So let's start off with regexes, or regular expressions. So a good example being on a credit card or a debit card, everybody has a number there, usually 16 digits long, but everybody's number is different, but those numbers all conform to a particular regular expression. So we've got a definition here of what a Visa card number looks like, MasterCard number looks like, for example. And what that means is when DataBelt does its scan, if it finds a document that contains a Visa card number, for example, it'll recognize it as conforming to this regular expression, and it'll link that regex tag to that piece of data, as well as any other associated tags. So against this Visa card regular expression, we can also specify what that data type is. Let's now cover off keras models. So where regular expressions work for text, keras models work for images and videos. So let's discuss an example. Let's pretend that you are suspicious that your employees are taking photographs of their pets, storing them on the work network, and therefore contributing to the trivial part of your ROT problem. Using a regular expression isn't ordinarily going to help you find those images, unless of course somebody has called the image cat picture or dog picture, for example. So keras models allow us to create an artificial intelligence model of anything we like. We can then compare that against our images and videos, and then where we have a match, it is automatically tagged. So I've created an example here called pets. Within pets we have three categories, bird, cat and dog. And all I've done is uploaded a number of images against each of the categories, and then we have trained DataBelt on the differences between birds, cats and dogs, so it can then go off and find any related files. The training process is very simple. This is one that's already been trained, and you can actually see the different epochs that DataBelt has gone through its bottlenecking cycle and also its fine-tuning cycle. This is where DataBelt is training itself on features that it finds within the example images, and it's constantly testing itself as well. So where it's going through this training process, it's actually choosing a subset of images that I've uploaded and actually testing its models against those same images to see if it gets a positive match. And this is a visualization of that process. So you can see its model accuracy has improved over time. Let's see then where our keras models and regex library fit within our overall ROT process. So on the left hand side there you have your data being fed through the DataBelt funnel into our first step, which is the classification engine. And at this stage your data is being processed ready to compare against those models and the regex library. So what that involves is an automatic processing of video data into frame by frame image data. We then run an optical character recognition scan across those frames and any other images you have to tease out textual information. And we also automatically transcribe any audio recordings that you have into text. That then allows us to compare all of your data against our keras models and regex library, and any matches that are found, the data is therefore updated with the relevant tag. We also carry out a metadata analysis at this stage, so teasing out information like created date and last modified date. All of that information then, including the tags, are then saved within one or more indexes. within the virtualized data lake. This is there where we run the first step of our ROT process, which is our ROT scan, to identify any pieces of ROT data and tag them, whether automatically or manually. We can then move on to our final step, which is the ROT data processing step, where we delete, move, or carry out any manual tagging that we need. Okay, so I've come over to our ROT module. You'll see on the left hand side we have some high level statistics, but later on I will come over to our data landscapes area of the system. This allows us to do a snapshot reporting and therefore do trend analysis to see how the ROT issue has changed over time. Moving down, we have our query templates, telling DataBelt that this is how we as an organization are defining obsolete data and how we're defining trivial data. So I'll show you the content of those shortly. We also at the top have our Run Redundancy Scan button. So when it comes to running the redundancy scan, we just need to say where within the business we want to do it. We would always recommend to select all data stores on their indexes though, just because if you confine a redundancy scan to one area of the business, it could be that a duplicate record exists in another area of the business. You wouldn't necessarily therefore find it. I can then schedule that scan, so this may be something that you do on a daily basis. Run the redundancy scan every single day, or actually I'm just going to, in this case, run it manually right now. So that's now running, and once it's completed, it'll go ahead and tag any of the documents that it finds with the redundant tag. I can then search for those records later and work out what I want to do with them. Moving down to our query templates then. So these are our definitions of obsolete and trivial data, and I'm just going to go into a couple of them now and explain the different types of filters that we have. So our query template for obsolete, we have a name at the top and we have a type. The type is important because that dictates the tag that is associated with any documents that it finds. We also have a description field there, so useful for any other users that are coming across a query that perhaps you've created to understand its use. Schedule settings are important. When this is automatically run, we need to tell DataBelt what to do with the results that it finds. So in this case, I'm choosing to not automatically delete documents because although they are obsolete, they may still have some use. There may be a very old supplier invoice, for example. So we're going to say that it's obsolete. We may still need to refer to it in the future. So perhaps actually the best course of action is to move our obsolete data to some archive storage, and that's what our checkbox here is for automatically moved documents. That might be preferred over deleting, and we want to tag the documents as well with the obsolete tag. We also have a keywords section, so I can type in keywords that I'm looking for, within the title or the body of the document. We got a few options here. I can set a fuzziness level, I can set a Boolean type, and then also define whether this is a prefix, a regular expression in its own right, and I'll show you shortly where the predefined regular expressions live within the query template. And also we can specify it as being a wildcard. So there's a lot of options there when it comes to keywords, and we also have a very handy cheat sheet which explains what all those different things do. Moving down, we've then got our classification filters. So the two here that are very key to our processes right now are regex tags and keras tags. So we'll come on to keras tags when it comes to our trivial data, but for now, here's our list of our regular expressions, and I've just got a couple here that are to do with our ROT process and are tagged specifically as being obsolete. What we've got then is a regular expression that is attempting to find a file that is empty. So we may say that an empty file has got no use to our organization, so we want to run a regular expression and say if somebody's created a Word document, for instance, given it a title but it actually doesn't contain any data, then we can go ahead and class that as obsolete. Also perhaps any documents that contain an old company address. So again, it might be relevant data, it might be a supplier invoice from years ago, and therefore it could be a few years old. So just a couple of examples there of how we can use regular expressions to try and tease out our obsolete data from within our various indexes. There are other classifications as well, so things like security ratings, different data types, business data ratings, etc. And the way these are set are that when the DataBelt index runs and it assigns regex tags and keras tags against our documents, those regex and keras tags are associated with these different data types that you see on the screen here. So it allows us to do some more filtering. So we may say, actually, we're interested in a certain type of data, but only if it's personal. Moving down to the additional filters section, you've got what I like to call the more traditional ways of filtering. So these are bits of file metadata, things like file name, parent path, file size. You can do filtering based on all those different things. But particularly useful to our purposes here when it comes to obsolete data is looking at things like created date, last modified date, last access time, and last change time. So we may feel the need therefore to pop something in to define that if a document is 5 years old, or perhaps it was last accessed most recently 5 years ago, then those are other things that we might want to pop into our query template to identify obsolete data. And then finally we just say where we're going to run this. And moving on to our trivial query template, it's exactly the same format. You see we have a name, we've associated it with the type of trivial, meaning that any documents found will be tagged with the trivial tag. And then moving down, what I'm going to do for trivial, I'm going to actually use a combination of regex tags and keras tags. So you'll remember we created our AI model of pets, which contained the categories of bird, cat and dog. So I'm going to say I'm interested in finding those types of things. So any photographs of pets that employees are storing on the network. What I'm also going to do is we've got some regex tags here that can help us with our trivial issue as well. So again, we may have a suspicion that people are using work-kit to produce documents that are of a more social nature perhaps. So maybe somebody's using their laptop and storing a document on the network that's to do with a party invitation. And this is just a really basic regular expression that looks for any documents that contain the word barbecue. And if we do find anything with the word barbecue, we're going to say that's trivial and we're going to delete it. So that's what we've set there. We've just set a couple of keras tags and our regex tag there as well. Again, you've got the same sort of metadata type filters there that you could apply. In this case, I'm just going to leave those as they are, and I'm going to search all data stores and their indexes. So now we have all the tools that we need to find, tag, and then automatically process, if we've opted to, our redundant, obsolete, and trivial data. So the scheduling process for query templates is really easy, just like we saw with our redundancy scan. They can be scheduled in the same way at any frequency. And then within our query templates, if you remember for trivial, we opted for the documents to be automatically deleted. I'm just going to untick that now just for the purposes of the demonstration. So this is a full end-to-end ROT process that once you have your prerequisites in terms of query templates, keras models and regexes, can be completely automated, manual, or somewhere in between. It's entirely up to you. So now that we have that automated tagging process in place, you saw that there were also some automated actions that could happen at the end of that, either deletion or moving the file to a different file location. What we can also do, of course, is just do the tagging and then process that data however we like. And a good example of this could be you may have some obsolete queries that define data that you're quite happy to delete automatically, and some obsolete queries where actually you need to check the data. And that's what we're going to do now. I've just created a basic query within DataBelt. I'm looking for all of our ROT data, and I'm just going to show you the very simple process that we go through now to process it. So we found 330 instances of data here, and we've got just one that I want to draw your attention to, kitten.mp4. Now that would have been a very easy file to find using a regular expression, but we have found it in terms of its keras tag match. So we have successfully matched that video against our AI model of a cat that we built using only around 25 images. And we can view the file because we might want to just double check it before we go ahead and delete it or move it. We can actually play the video clip and we can confirm that this is trivial data. This has got nothing to do with our organization. And scrolling down just to show you while we're here, we do have our video frame classification timeline. And this shows us for all of the frames that DataBelt has processed, what keras tag matches DataBelt has found. Now in this case, frame 119, we've got a very high percentage match here for cat, 99.714%. And you'll see, just out of interest, that bird and dog have also been analysed, but incredibly low percentages compared to cat. So what I can then do is select one or more of these files. I can also select all if I want to. But let's say I've gone through all of these and kitten's the only one that I'm interested in. I can then go ahead and do whatever I need to. So I can manage tags for that particular file. So maybe I need to do some manual tagging. There may be something that for whatever reason we don't yet have a query template for, but there are some things that I found that I think might be obsolete or trivial. I can go ahead and do some manual tagging. I can also move the records, so I can send these to a specific file share, transfer those over. So again, perhaps going from a high cost storage solution to a lower cost one, or I can go ahead and delete that record. Processing our redundant data is very similar. I've got a few possibly redundant files here, some duplicates. I can go through and select which ones I would like to process. In this case, I would like to delete them. And I can also, by clicking on the action gavel, actually have a look at the content of those files. So you can see here, the content of that document. I can also download the original if I'd like to, in order to double check what's on there before I delete it from the relevant data store. We also have quite a bit of obsolete data here, so based on things like create date, last modified date, etc. And we've got an invoice here, which I can open up. Again, I can download the original and I can actually view the content of it. And I can see that it's referencing our old address. So we've got a match on the Unit 69 regular expression, and that's why this has been flagged as being potentially obsolete. So again, I can go through, select my obsolete data and get it deleted, or possibly in this case move this to a different location. And we can also do manual tagging. So a couple of Dark Knight films that have been shown to me here as potential duplicates. But I may actually then start thinking about other query templates that I might want to build. If I'm seeing that people are actually starting to use the work network to store things like movie downloads and song downloads, that can feed into my query templates so that I can capture these as trivial data going forwards. But in this case, these have been flagged as duplicates, but maybe I just want to go through and do some manual tagging at the moment, and I can then go ahead and specify these as being trivial data. And finally, as promised, I've come over to our data landscape module, and I'm just going to show you some of the trend analysis and snapshot reporting that we can do here. So I've set up a visualization query that is looking for ROT data, and I've manually ran it a couple of times, but I've also set up a schedule for this. And then moving down, we have trend visualizations for ROT. So these are some example charts showing you over time how the ROT situation is changing. And so this will just build up and build up each time that schedule query runs. Data will be added to these reports. So whereby the top charts provide you with trend analysis, scrolling down you're then able to select a specific snapshot in time and then to view some really detailed information. These are just two examples of reports that you can have, but you can actually create your own very easily using our aggregation visualization builder. And just to give you an example of our sunburst chart here, I can have a look at the JPEG files that existed at that time that were classified as ROT. I can give it a click. I can then see the Keras models that matched. So there was a cat image. Also the regex pattern that matched. So we matched against our street regex. We can also see what the file sizes were. So some really detailed snapshot reporting, not just showing you the trend analysis, but allowing you to drill into the data that existed at that snapshot in time. Thank you for watching. If you'd like to speak to me or our other data experts at AIM about DataBelt or any of our other products, please get in touch using the email address or telephone number on screen. We can provide you with customized demonstrations and a free proof of concept so that you're confident in your choice of data governance software.